Honorable Chairman, distinguished scientists, in today's lecture, I'm going to focus on the Mesozoic magmatism in India with special reference to tectonic and petrologic significance. The Mesozoic magmatism in India is one of the most spectacular events in the history of our planet, and special reference to India in particular, because during this period the magmatic rocks that are formed in this country is unparalleled to the entire history of Indian subcontinent. Now, in the present discussion, I have confined my subject mainly to Rajmahal volcanism, in which I have worked in detail with some passing reference to silicious basalts, and I have also dealt two new aspects of Deccan basalts which have not been tackled earlier, that is on the migration of flora and fauna and the significance of black cells occurring as interlapping beds within these lavas. And I'd like to announce through this conference that we have reported first time the occurrence of ultra high pressure metamorphism with the occurrence of quartzite in the Naga Hills ophiolite. The paper is under publication and is sub judice. Details of could not be discussed in this lecture. The geological formation of Rajmahal Hills in the eastern part of India. Now here we find the western part of the Rajmahal Basalt is in contact with the Gondwana formation, whereas in the east, northeast, we find river Ganga is flowing. The insert map gives an details of the location of the Rajmahal, and it is in fact located in the northeastern part of Chotnagpur Plateau of Precambrian age. Now, the map shows several eruptive centers or vents through which the lava had erupted. I'd like to emphasize here that in course of our investigation we have established that the eastern part of the Rajmahal Basalt is dominated by felsic pyroclastic rock, whereas the western part we find they are essentially haloclastites, very rare occurrence of pyroclastic rocks. The haloclastites suggest the magma must have erupted in water or due to ferrodomagmatic and formed a ferrodomagmatic eruptions. It shows the borehole lithology from the southern part of Rajmahal basalts. In this we find there are several layers of eruptions, and in the lower part we have the occurrence of thin interbeds between the lava, between these successive lava eruptions. We find the occurrence of whites indicated by a red arrow and the blue rectangles showing the occurrence of black cells with organic debris of dead marine organisms. They have a special significance because they are formed possibly due to emission of your toxic volcanic gases, and as a result of which the life at that period in the marine conditions were not sustainable, and the animals died, and gradually they settled down in the in the ocean bottom. The black cells are succeeded by lava flows in the Rajmahal and Deccan basalts. The photograph A, is a field photograph showing occurrence of tube breccia with spindle-shaped volcanic bomb formed by explosion of volcanic outbursts. The bombs are thrown out to great heights in the atmosphere due to explosive activity. These are embedded in ice beds, showing sagging effects they are found near Barhait in the eastern part of Rajmahal Basalt. And the photograph on right is a lens of andesite developed on cooling. This is also part of pyroclastic rock. Some photomicrographs of the different rock types encountered in the Rajmahal basalts are shown here. One is the Rajmahal hyperthin basalt in A with intergranular texture, and B is a xenolith occurring within the hyperthin basalt. The outer rim, it is a silt. The outer rim, you find it has undergone melting, and that in fact contaminated the basalts. And C is a xenocrest of fractured juvenile quartz tephra in hyperthin basalt. And the fourth is again one of the finest slides ever to be captured from the Rajmahal. It is a phenocrest of tridymite, a high temperature polymorph of quartz, indicating that magma must have attained a very high temperature exceeding 1000 degrees centigrade. And the tridymite showing tile structure. A few photographs of the pyroclastic rocks are shown here. The first two, A and B, are the lithic tubs with fragments of rocks, and the lower two, C and D, are representing ignimbrites with fiamme structure. The C and D is some spherules within glass in rhyolite. In the earlier two slides, I have shown you some of the variation in the rock types that we encountered in the Rajmahal basalt, and the pyroclastic rocks in this from the eastern region. And in this slide, I have shown the photomicrographs of hyaloclastites. These are formed due to magma water interactions, and when the lava erupts in water, so there is a interaction between lava and your water due to difference in temperature, and the first thing we get in consequence is the quench texture. I have shown here three different quench texture. One is the formation of sideromelain, A. Second is the quench texture with concave fractures in brown glass of basalt, and the third is the formation of long acicular pyroxene in basaltic ground mass. The whole thing is basalt, and you get long your pyroxene as a result of quenching. The D is, it has a photomicrograph a fine tuff with alternate layers of pumice and crystals showing normal grading with upward decrease in grain size. And E is again density layering in fine grain tuff with mafic bottom grading upward to feldspar rich layer. And the fourth one, all these A to E are the hyaloclastite. Last one is the a brecciated welded tuff, and you find with resolved clinopyroxene and plagioclase grains in it. Photographs of the formation showing the formation of paperites. Now, paperites are formed in marine conditions due to simultaneous crystallization of pumiceous glass and unconsolidated clastic grains. So this has been encountered in the western part of the Rajmahal, and the slide B is the oolite, which is encountered in the Dudh Khol and in the eastern part of Rajmahal, which supports the possibility of hydrocarbons both in the Rajmahal as well as in the adjoining Bengal basin. Part of the variation or characteristics of Rajmahal basalts are shown in this slide, in which you find the Rajmahal basalts varying between basaltic andesite, dacite to rhyolite, and in slide B you find the basalt can be divided into two distinct categories. One is the primitive basalts with low strontium isotope, and the contaminated one with wide range of variation in strontium isotope. And it has been found the primitive basalt has almost a flat, incompatible element variation pattern, whereas the contaminated one has wide variation in the contaminated in incompatible elements. We have tried to examine what is the nature of texture of these two magma types, and it has been found texturally they can be distinguished that the early basalts, which are primitive basalts, less fractionated, and they are medium to coarse grain and porphyritic in nature, whereas the late eruptions are largely contaminated and they are characterized by texturally fine to very fine grain types. So these are the two main types of basalts that we have established from the Rajmahal. Now in this we have the A showing hand specimen accessory bomb with onion cell-like structure. These are found from the eastern part of Rajmahal, and the other one is bentonite deposit in the Rajmahal basalt, which is a product of your felsic tuff, and these bentonite occurs as interpets as thin lenses in the Rajmahal basalts. Now, the conclusion that we have arrived at from the detailed studies of all these features, that the subaerial pyroclastic deposits are essentially felsic in composition and confined to the eastern part of the Rajmahal. The other thing that, in contrast, the western part of Rajmahal, they are a product of phytomagnemic activity due to magma-water interaction. The interesting part of the bentonite is the occurrence of illite that suggests that bentonite must have formed in marine conditions. This, together with the occurrence of oolite, further confirms that they must have formed in coastal environment of at shallow water. The other conclusion that is derived is that the occurrence of black shells at different order in different levels in the lower part of the stratigraphic column, which suggests that there have been your anoxic conditions and during early part of the Aptian time, and the eruptions, the late eruptions of Rajmahal are essentially subaerial and characterized by the absence of interface. Another interesting feature that we have observed that rhyolite is not connected to the main lava. Rather, they form by crustal melting. This gives a stratigraphic of the lavas are succeeded by layers of black shells, and such black shells are rich in debris of dead marine organisms, which have been studied in great detail by this author. We find this has been worked out by Cripps. It is considered to be, I have judged it to one of the finest work which has been done. Little stratigraphy of a section of Deccan basalts from the western coastal margin, studied by Shane Sharma, is shown here that the lenses of pumice occurring at different levels together with lignite and showing alternate layers of lignite and black shells. The layers of lignite carried different flora and fauna from distant land in post-Deccan type activity, confirming migration of flora and fauna. Thank you.